So what we're going to do here is we're going to continue Lesson 11, Part C, Day 2. This is a quadratic formula. Quadratic formula is a very nice thing to know. It's nice to use. And when it's done correctly, it will always give you solutions to a quadratic function or a quadratic looking function, because we actually can use it more than just something to the second power. And those can be real solutions or imaginary solutions. And remember, the real solutions are either 2 or 1 or no solution, or 0 solutions, which would be the imaginary. Now, my biggest thing is that if you want to use the quadratic formula, then right now we need to build it. I think it's kind of nice for you guys to see, where does it come from? What does it look like? Most of us should have already seen it at least once already in our math career. So, how do you build it? You build it by using completing the square. Those 6 steps that we did not too long ago with this. Now, I'm going to change this before you write it down. Okay? I'm going to change it. Take this out of here. I'm going to put the equal sign on the other side. I put the 0 on the right-hand side because it's going to be a little bit more conducive to actually building the formula. There were 6 steps. I'm not including that in here because you guys could look back at that video or the notes for that. But if I was going to use the completing the square, what's my first step? It has to be set equal to 0 because all of our quadratics when we're solving are equal to 0. So it's a little different than our first step of completing the square. Separate the variables. Which ones are the variables? They all look like variables, Mr. Konchak. Here's the thing. This is a quadratic in standard form, where A, B, and C are not variables, but they stand for numbers or coefficients that are real. So therefore, A, B, and C are not the variables. The x's are. So the only one that does not have a variable attached to it is C. So I think everybody should agree I am going to subtract C from both sides. And when I go to rewrite this, it becomes ax squared plus bx. Do I leave myself space? We've done that before, right? Do I leave space or not leave space? If A is 1, can you guarantee right now A is 1? No. A is A. A sometimes is 1, sometimes it's not 1. So therefore, I cannot guarantee it. I do not leave the space, so I want to get rid of it. And how do I get rid of A? Or guarantee that A spot will be 1? Divide by A. So I go through and divide by A. 0's gone because I put the C, the negative C, or the minus the C on both sides. Okay, so I'm hoping everybody understands that I'm going to divide everything by the A. So A, x squared divided by A just becomes x squared plus no, we could say it's bx over A, but again, I like to keep my coefficients off, so I am going to put it as b over ax. That way I know my coefficients. Now A is by itself, or A is 1, so I can do plus something equals, and I'm going to change it from what we have been doing, just because it's going to be more conducive to actually seeing the formula starting to come out here. I'm actually going to put the space first, and then do minus C over A. Okay? So they're still adding something to both sides. It's there. Now, if I'm looking at this problem, what's my next step? Divide B by 1/2, or take half of B and square it and add it to both sides. The question is, what's B? What's B in this particular problem? Is it B? Yeah. What's that? It's B over A. So the question is, how do I take a half of a B over A? It's no different than we've done before. Half times B over A is going to equal, multiplying fractions, b over 2a. Hey, b over 2a, that should look kind of familiar to us. So, going into my problem, I need to do what with that? Square it on both sides. Okay. Now, remember, we leave it as 1/2 b squared on one side, and the other side we actually do the math, or we simplify it. How do I square a fraction? Top and bottom, so it becomes over 4a squared. Yes. Now we're at this point. The left side should equal what when I factor it? X plus b over 2a squared. Okay. I'm thinking we might have a problem with the right-hand side trying to get those put together, right? Why? Why were we going to have problems with that? What are they lacking?
All the same
common denominators. So therefore, the common denominator between 4a squared and a is 4a squared. So that means the c over a has to be multiplied by 4a to the top and bottom. And so, if I go back to the bottom here, I get b squared all over 4a squared minus, remember when we do this we like to put variables in order, right? So what is it minus of? 4ac all over 4a squared. You guys starting to see something familiar? Okay, we got a common denominator, so might as well put those together. So that becomes b squared minus 4ac all over. Hey, that's very familiar, hopefully, for most of us. We're building a quadratic formula. No, we do not have to do this for every problem. We're building it now. Okay? It's building the tool so we can use it. Next step on the list, I think this would be step 5, I think. Square root both sides. Don't forget. Plus or minus. But we do know that when I square root a square, they will cancel. So x plus b over 2a is equal to plus or minus the square root of b squared minus 4ac all over 4a squared. But wait a minute. We're square rooting a fraction. What can we do? I could square a fraction on top and bottom, so I can do what with a square root? Separate and square root the top and square root the bottom. So it would be plus or minus the square root of minus 4ac all over the square root of 4a squared. I'm not doing anything with the left-hand side. I'm going to leave it. What's the right-hand side look like? Can I do anything with the top? Can I square root that?
No.
Why? Why can I not? Because we're adding or subtracting going on. I don't have any rules for that. So that's going to stay as the square root of b squared minus 4ac. The bottom, though, it's a single term, right? So if I square root a product, I can square root them individually. What's the square root of 4? Square root of a squared. Hey, that really should be starting to look really familiar to us, right? And then, kind of the last step in a ways, says to get what to the other side? Not the x to the other side. The b over 2a. And I've been telling you all along, where does the part that you bring to the other side go? In the front. So, we end up with x equaling the opposite of b over 2a, or a negative b over 2a. plus or minus the square root of b squared minus 4ac all over 2a. I can't just cancel the other two. But I do have two fractions that have a common denominator. Can I put them together in one? And so I end up with x equals opposite of b, or negative b, plus or minus the square root of b squared minus 4ac all over 2a. And that, ladies and gentlemen, is called the quadratic formula. Now that we've built it, let's use it. But how do we use it? It's with these 4 steps. I want to see these 4 steps used. The reason is because people, our students, are making very simple mistakes because they're trying to do too much at once. The first thing I want you to do, just like solving by factoring and all of that, and even graphing, is generally we say set equal to 0. We set the quadratic equal to 0. I then want you to list A, B, and C separately. A equals, B equals, C equals. Don't mess up, because A is not 2x squared. A would just be 2. So be very careful on that. Number 3, anytime you use a formula, you should always be writing it down, especially the very first times you're learning it. Now granted, we're going to assume that this is kind of the first time go for people. All the way through this next quiz, you'll be writing down the formula every time. And it's just a good habit to do. It commits it to your memory. And when you're doing your homework tonight, do not refer back to your notes. You will do this from memory. And the last one is you fill it in, aka play coach, substitute in, and evaluate using their order of operations correctly. So the example that I'm giving for this is solve x squared plus 10x plus 30 equals 9, which actually is problem, I think, 12 or 7. I think it's problem 7 from the completing the square worksheet that I gave you guys. So you guys should already know the answer because we completed the square on this. So now let's use the quadratic formula to see if we can get the same thing. So step number 1 said what? Set equal to 0. And how do I effectively do that? Subtracting 9 from both sides. So x squared plus 10x plus 21 equals 0. Second step says, list A, B, and C. A equals 1. B equals 10. C equals 21. Now, if any of those up there were minuses, then you know it to be a negative. Because our original formula is ax squared plus bx plus c. So anytime there's a negative, that means it should be our minus sign, it should be negative. And next step is write down the formula. What's the formula? Negative b plus or minus square root b squared minus 4ac all over 2a. Okay? Commit that to memory. Now we just got to play coach. And we play coach. When we play coach, we use what often? We use substitution. We use parentheses. So that comes very handy when things are negative. Is b negative though? No, but it is 10 plus or minus square root of 10 squared minus 4 times something times something. The first one is a 1 and the second one is 21 all of that. Make sure your fraction bar goes all the way underneath everything. 2 times 1. And now it just becomes an evaluation game. Evaluate using PEMDAS, order of operations. Make sure you do things correctly. What is the opposite of 10? Notice I'm using opposite instead of negative. Because if it is negative, it becomes positive. 10 squared. 100. Minus. Now this is the point where I would actually get rid of any negatives if there are any. And I would say something on the lines of negative 4 times a positive times positive. We know it's going to be negative. And what's 4 times 1? Times 21. 84. Notice I'm not trying to do all of that in my head at once. I'm not doing 100 squared minus the 84 right away. And all of that is over 2. Keep going. X equals negative 10 plus or minus square root of 16 all over 2, which equals negative 10 plus or minus 4 all over 2. Those are nice numbers. Do not leave it in that form. Break it up. So it becomes negative 10 plus 4 all over 2. And that would be negative 6 over 2, which is negative 3. And the second one is negative 10 minus 4 over 2, which is negative 14 over 2, which equals negative 7. There are 2 answers, and the 2 answers are negative 3 and negative 7. You could check those back in the original problem to see that they both give you 0, or in this case 9, because we don't have it set equal to 0 in the beginning. Left side should equal the right side. It will always give us solutions. Your homework is on page 88, and it's 8 through 12. Have a fantastic evening.